Yeah, I want to reiterate a lot of the thanks that Mark already put out there to the New World Foundation and everybody involved in the Farm Hub here, and particularly for Justin to keep us all in line and let us know when we need to come here and do certain things. We were out in the winter plots 2 weeks ago. Was just the perfect timing to get disease ratings on the winter grains. We're going to try to get ratings of what we can in these spring plots today, but one of the important diseases is just starting to show now, the Fusarium head blight, so we'll need to be back to finish that story. So we are very much keyed into the variety evaluations that Mark has talked about here. We do other things as well in other locations. We test biological control measures, we test fungicides, we look at cultural practices, we look at various other things that are also part of the story in reducing the risk, maximizing the yield and quality, and reducing the risk. But we're growing these crops in a, this really puts the exclamation point this year on basically a pretty wet environment to where the majority of our grains are grown, which is in more toward an arid environment. So what comes along for the ride is a lot of good stuff like great yield potential, but coming along with that is fungal diseases in particular, also some bacteria and viruses, but principally fungal diseases. And each one of these crops has its own sort of list of fungal diseases. Most of these organisms that attack the grain crops are very specific. So for instance, if you look in number in the barley and the wheat, you'll see some white cottony growth on the leaves. This is the powdery mildew fungus. There's a different species of powdery mildew fungus that goes to wheat from the one that goes to barley, from the one that goes to rye. Okay, so they're very highly specific. So I get questions, well, I saw all sorts of powdery mildew in my barley, but none on the wheat. Well, it's a different organism. They have a very similar life cycle. The rust diseases are very similar to that. So when we were out here with Justin 2 weeks ago, we found a variety of the leaf rust fungus on each of the rye, the barley, and the wheat. Three separate different fungi all closely related, obviously, cause leaf rust on those different crops. And we actually saw a number of varieties in the barley and the wheat that were much more susceptible to the races, the varieties of the rust fungi that are in our environment this year than most. So this is really important information. These organisms exist in races, and so it's important not just to look what happens in 1 year in one place, but Mark has mentioned he has variety trials in different parts of New York State. There are people, we have a communication with our network of pathologists and breeders across the country. And sometimes new races evolve, get selected from tiny numbers that they increase to cause problems on crops that look to be resistant before. So you don't just get an answer one time and it works forever. This variety is resistant to powdery mildew, this variety is resistant to rust. There's kind of a dynamic to that. The other thing that you'll see in each of these crops is each of them have a number of fungal pathogens that cause problems that we just kind of lump together to call leaf spots or leaf blotches. Okay, so they all start from spores that land on the leaves, and when there's wet conditions, those little spores, they germinate, they develop a little germ tube, and then they penetrate into the leaf and start their infection. And so in particular crop like wheat, we see two particular diseases here. We see Staganospora nodorum blotch and Septoria tritici blotch. This year I saw a lot of Septoria, a lot of Staganospora in the wheat. There are, don't need to learn the Latin names, but I just want to make sure that you know there's not just one thing, one organism that causes leaf blotch. And a wheat variety, for instance, can be resistant to one and quite susceptible to a different one. So typically what we do when we rate varieties, we rate for the symptom group. We'll rate how much of the top leaf area that should all be green, how much of it is turned brown prematurely because of these leaf blotches. We estimate the percent of that area, and we can compare varieties that way. But then we take samples of those leaves back to the laboratory, we incubate them, and we grow out and we see what fungi are attributed to that problem in a particular location. And this varies by location and year. In barley, I think you saw a couple of those varieties down there. There was essentially no green leaf area left on the entire plant. And that's bad. That's the photosynthesis, that's the yield you're looking at there. And from those I was seeing almost entirely the net blotch organism. So we're seeing, just in this little trial here, we're seeing really dramatic differences between varieties in their susceptibility to net blotch, to powdery mildew, in some cases to rust, etc., etc. So the kind of granddaddy of diseases that we're most worried about because of its concern, all those things affect quality, but primarily yield. The one we really sort of stress out over a bit is Fusarium head blight, because yes, it hurts yield, but it makes the product unsaleable because of contamination with what most people know as vomitoxin, deoxynivalenol. And this is a fungal produced toxin, and the FDA has guidelines in finished food products for our consumption, whether it be bread or a beverage or whatever, of 1 part per million in the diet, okay, in what we intake. So I can just tell you, in a circumstance like this year, it's not unusual to see 4 or 5 parts per million contamination in a commodity. So in the case of grain for bread, we need to get that down to 2 parts per million. As a rough guide, in the milling process, we can take starting grain at 2 parts per million and generally mill it down to about 1 part per million, okay? The toxin is very heat stable. So even baking cookies or bread or anything else through that process, we don't get rid of much of the toxin. It's a highly water-soluble toxin, so we're worried about the acute effects. It doesn't accumulate in the body like some other things. It gets flushed out with the urine, but you're going to have stomach upset and possibly vomiting, and so are animals with simple stomachs. I work with some of the pet food mills in the western part of New York State, and they have very strict limits on vomitoxin and things that go into pet foods. So that's the game, is we need to grow the commodity as clean as we can. We're never going to be free of this disease or this toxin in a wet production area like we live in here, but we can really reduce the risk. We can start the risk reduction by our crop rotations. Okay, so probably the biggest source of the spores of this fungus are overwintered crop residues, particularly cereals and especially corn. So corn stalks are a real factory for producing spores that get into the air. So if we're following small grains, not after another grain crop, or certainly not after corn, that's a big help. Rotations where we follow these grains after a legume or vegetable crop, soybean is a perfect preceding crop, that helps you quite a bit, but still not enough. So I've done a number of research projects over the years, and we think we can reduce the risk by maybe a quarter with the rotation and some cultural practices. Now the next important thing is the choice of varieties, and Mark's tables include some ratings for Fusarium head blight and for the toxin for Don, and there's nothing out there that you can grow that's free of it. Okay, so let's dispel that rumor. We talk about resistance, we're talking about moderate levels of resistance, but helpful levels of resistance. And amongst, particularly on some of the wheat classes, we can cut the risk down of toxin contamination by a third to a half, probably. So if you have really favorable environment, which is wet weather at the time the heads are emerging in barley or the anthers are coming out on the wheat heads, you can overcome some of those tools. So the third tool that we use in conventional farming is we use triazole fungicides, and they are very effective when applied just at the full head emergence in the barley. or at the first yellow anther showing on the wheat or on the rye, and we can get about a 50% reduction in the risk by a well-timed fungicide application with a Prosaro or a Caramba. So if you're doing this organically, you don't have that tool. We are doing a lot of research looking at organically improved materials, and there are some things that have a little glimmer, but nothing really consistent in the organic tool chest right now that can be applied as a rescue like that. But that means you really need to up the ante on the variety selection and on the cultural practices if you're trying to do this organic. You had a question, sir.
So you have to, if you're going to apply this kind of fungicide, you have to do it before you know whether it's infected, right?
That's exactly right. So the application is, so this is flowering. This is the beginning of anthesis flowering. You can see those yellow anthers coming out of the florets. A little later, those will turn white, but this would be the perfect timing for putting on a triazole spray for those that are doing that. We are looking, if you want to pass that around, we are looking at some things like coppers and microorganisms and various other kind of things that might have some role in an organic operation, but so far, and we get some control of things like mildew to some extent, but fusarium is a really tough one. And so that's going to require a lot more work to really have some alternatives there. But we've made, when I say we, the country, the industry, breeding programs like Mark's, companies, etc., have made some real strong incremental gains over the last 20 years, especially on wheat. A little further behind on the barley, there's some, Mark mentioned Quest on the spring barleys has some pretty good level of moderate resistance. We're kind of searching in the two-row barleys to find much effective resistance there, but that's a strong goal.
Question in the back.
Question in the back, sure.
Yeah, I'm wondering about plant density, less dense planting as a way to increase air circulation, dry out plants.
Okay, the question was planting density as it affects kind of the canopy architecture and the humidity and whatnot, and that's a good point. So particularly if you notice some of the plots that have powdery mildew, a very dense canopy is very, powdery mildew, it's not so much about, doesn't really need rain. It needs humidity in the canopy to get powdery mildew development. So a denser canopy, poor airflow is going to be more prone to a lot of these fungal problems. Good point. Yeah, Larry?
Gary, with Don, is that seed transmitted? So if we've got an infected crop we can't sell for milling,
yeah.
Can we use that for cover crop, and are we putting ourselves in jeopardy in the next crop?
Okay, great question, Larry. So the question is that the fusarium fungus is in the seed as well, and so we're not only talking about grain, but now we're talking about seed that gets planted. And so the quick answer is, as long as that seed is still alive and germinable, it would probably do pretty well to plant out in the field. If you're in a conventional situation, if you can apply a seed fungicide, it'll help even more. If we have a real drouthy situation, we can get into what we call a scab seedling blight, where we have the fusarium infected kernels. But by and large, it's not, as long as the seed is still alive with a germination test, we don't have much problem. And as far as introducing more of the fungus pathogen into the soil, into the area, the organism is so common in the area now that it probably, the little bit that you're going to apply with the soil with the seed is not really going to shift that equilibrium much at all. For the infection of the heads, the principal inoculum is what's coming out of the air, not what's coming out of the soil. If we were looking at crown rots in the wheat plant, the soil inoculum has a role to play on that, or like on stalk rot of corn. But the ear rot of corn and the head blights of the small grains, it's basically about the airborne spores in the air. The fungus produces two spore types. One that just is in a kind of a gooey orange matrix, and it just gets moved by splashing raindrops. So if you had cereal stubble in this field, it would splash it to the next susceptible crop. but it produces another spore type that produces a little bluish black body, looks like a little volcano on the surface of the like corn debris. And there's a hydrostatic pressure in those little things. They push them out those spores, discharge them under pressure, like little cannons firing, maybe 8-10 millimeters, enough to be picked up by turbulence in the air. And on a sunny day like this, there's convection currents mixing this air all the way up to the lowest layer of clouds. So once it gets beyond the boundary layer of the crop, it gets mixed all the way up in the clouds. And we've done some work with aerial remote controlled aircraft, and we can catch viable spores at miles away from probably where they were produced on the ground. So this comes back to what I was saying. You can control your stubble and your rotation in your field and have some impact, but it's a neighborhood concept as well. If there's a lot of crop production in the neighborhood, you're going to get enough in the sky coming. But it's kind of the perfect storm pulling all these things together.
Does is it, if you had a cornfield but you didn't have any other wheat fields around, is it have another host? Is it going to be there anyway?
It has tremendous number of hosts. The Latin is graminearum. It's the fusarium of the grasses. So all the wild grasses, everything. And we can get infection even of things like soybean stubble and things, but the most spore production is on the cereal residues. That's the numbers game. That's where we get the big number of spores that get into the air. I should comment a little bit more. So we talked about the situation with vomitoxin and grain for baking. Let's talk about for malt a little bit. So barley or any other grain that's going to be malted, as you I'm sure know, hearing Andrea and others around here talk about malting over the years, you're talking about germinating seed under controlled conditions. That's what's going on to start the conversion of the starch to get the enzymes to lead it to sugar. So the fusarium fungus is still alive in those seeds. So even if you rinsed every bit of vomitoxin out of that barley when in the steeping and when you're starting to make malting, there's still a living fusarium in those seed, and under the moist conditions in the malt house, they can produce more toxin. So this is the concern for malting is really more about the fusarium that's in the seed because of its potential to make more toxin. But we still make decisions based on the toxin we can measure, because it's not very easy to quantify fusarium. It's pretty reliable to quantify the toxin, but it's really the flag that tells us that the fusarium's in the seed.
Can those be killed with the